The universe is tremendous, and our planetary group is just a minuscule piece of it. The expansiveness of the underlying photographs from James Webb and the interstellar goes of Explorer 1 and 2 show that the universe is huge, past the planetary group. Anyway, the heliopause has as of late experienced many unnerving changes, and apparently, something is endeavoring to enter our planetary group from interstellar space. In the present video, we'll examine the disturbing new danger found by the James Webb Space Telescope as it moves toward our nearby planet group. The heliopause is the limit between the planetary group and the interstellar medium. The heliopause is the limit between our planetary group and the remainder of the universe. Consequently, moves in the heliopause are quite compelling to scientists at Long Pinnacle. Yet, our momentum heliopause models don't represent specific frightening changes that new examination suggests. The modifications were uncovered through a survey of information gathered by NASA's Interstellar Limit Pilgrim IEX. As per experts, the heliopause was recognized by IEX after the satellite got a progression of increasingly enthusiastic neutral iotas. Also, you are right, this is a significant improvement. Further, the heliopause has moved, as found in the Explorer 1 and Explorer 2 information. Researchers found that the heliopause changed so definitely between the times Explorer 1 and Explorer 2 entered interstellar space that it straightforwardly clashes with our current comprehension of the planetary group's external limit. These unexpected changes could likewise make sense of why the two tests are isolated overwhelmingly as they enter the interstellar medium. In October 2022, specialists wrapped up the paper on the point, publishing it in Nature Cosmology. In it, they framed how the situation would develop and classified the heliopause changes as potentially disputable. Hence, they intend to keep investigating the farthest reaches of our nearby planet group with NASA's Interstellar Planning and Speed Acceleration Test to acquire more top-to-bottom knowledge of interstellar space and a better handle on these changes. Researchers, however, should manage with the data we already have, including the outcomes from shuttles like the Explorer tests and the James Webb Space Telescope. But have you at any point given any thought to how the heliopause was first found? If you don't have the foggiest idea of the background, we'll fill you in. Once the heliosphere was found in the mid-1950s, the heliopause was a natural outcome of the space age's dawn. Once the heliosphere was demonstrated to exist by satellite information, physical science models of its interaction with the interstellar medium displayed undoubtedly that the heliopause must exist somewhere. Trailblazer 10 and Trailblazer 11 are the most probable candidates for the earliest space apparatus. Subsequently, proof for the heliopause began to arise. Long stretches of information on sun-powered breeze activity have been gathered by the Trailblazer tests since their 1972 launch, stretching out to almost 67 astronomical units away. Anyway, Pioneer 10 conveyed its last rational message back to Earth in January of 2003. In 1993, anyway, information from the Explorer rocket affirmed the presence of the heliopause with more significant sureness, as well as providing the first direct proof of a quantifiable limit with interstellar space. The two tests were in a favored situation in the interstellar medium to identify solid low-frequency radio waves created by the savage cooperation between extraordinary sun-based winds delivered in May and June 1992 and the interstellar medium. Anyway, the discovery that cosmic huge beams had increased while solar wind particles had diminished was made by Explorer 1. The most convincing proof for the heliopause presence came in 2012. The transmission demonstrated that Explorer 1 had entered interstellar space. In spite of the seemingly obvious proof, the phenomenon wasn't isolated to Explorer 1. In 2018, Explorer 2, which is on a far different trajectory compared to Explorer 1, saw the same rapid drop in solar wind particles and spiking cosmic beam particles. How about we examine what an unbalanced heliopause really is and why researchers are so stressed about it? A good analogy for the heliopause, if we are to think of it as a limit, would be a breeze sock that is constantly being extended and pushed by the wind. How about we assume that this is the state of the heliopause from a purely physical perspective? A comet that is approaching the Sun and is produced from the sublimation of gases surrounding the comet center is another close analogy, and that is how the heliopause shows up to your eye. This implies that the heliopause has a particular structure that happens when the solar wind crashes into the interstellar gas and magnetic fields outside the heliosphere, which apply a contrary force. Notwithstanding the force of the interstellar wind on the heliosphere, the inversion of the Sun's magnetic field extremity throughout the solar cycle contributes significantly to the state of the heliopause. When the solar wind pushes against the interstellar wind, It causes a three-layered sine waveform in the solar wind, which in turn influences the formation of the heliosphere and heliopause. The only artificial objects known to have entered interstellar space so far are the Explorer tests, which crossed the heliopause in 2012 and 2018, respectively. Their observations were critical in establishing the presence of the heliopause, but it is proof that a system consisting of only two sensors can't accurately detect a three-dimensional structure in space. Anyway, what we should be stressed about is the lopsidedness of the heliopause, which could prompt an attack of extraterrestrial life. While clearly, interstellar space lies beyond the heliopause, much more in regards to the heliopause and what lies beyond it is still unclear and easy to refute. For years, scientists have speculated about the presence of a bow shock just past the heliopause, where solar wind particles and the heliosphere's magnetic field disturb but don't completely overpower the interstellar medium before them. The theory of a softer bow wave has gained recognition due to the argument that the planetary group isn't moving quickly enough over the interstellar medium to cause a shock. The Ibex strip is a band of intense ENAs that extends along the heliosphere and is notably brighter than the adjoining ENAs, presenting a difference. However, no one has yet provided an adequate explanation for the occurrence of the Ibex lace or its implications for current heliopause models. An examination student at the Southwest Exploration Establishment named Justina Sol has argued that the Sun is like billions of other stars in the universe, suggesting that some of those stars have decayed like the heliosphere. But this decay is one that we can notice closely because we are within it. Therefore, we really need to fill in our knowledge gaps regarding the neighborhood, expanding our perspectives to the remainder of the universe. Anyway, imagine a reality where there is no heliopause to safeguard humanity. We people are strangely lucky to have that solar windshield, the heliosphere, which the Sun provides. It absorbs 70% of the interplanetary cosmic rays. Without the heliosphere, vast beams would slam into Earth, connecting with it in a way that would dramatically increase the radiation we absorbed, searing life on Earth like eggs in a skillet. On the contrary, it isn't known how this wall of hot plasma will affect interstellar travel if and when we choose to travel beyond Mars and finally leave our nearby planetary group. All things considered, considering that Explorer 1 and 2 arrived safely, at least our interstellar ships don't appear as though they will take an excessive hit. We don't know what the plasma wall will mean for living creatures like us. Consequently, this is a subject for further discussion. The investigation of the heliopause, as well as interstellar space overall, is vital for growing our understanding of the universe as mankind continues to send tests into space. One of the key objectives is to learn about the limits that define our nearby planet group and how they interact with the surrounding interstellar medium. This data could have significant ramifications for our understanding of other star systems and the conditions they harbor. The heliopause plays a crucial role in safeguarding life on Earth by protecting us from harmful astronomical rays. These high-energy particles originating from outside our nearby planetary group can have various damaging effects on living organisms, especially in space. In addition to the heliopause, the Sun's magnetic field serves as a natural barrier, redirecting these particles and helping to maintain the fragile balance of conditions that make life on Earth possible. Anyway, the changes in the heliopause seen recently raised significant questions about whether this protective barrier could be weakening or becoming unstable. The fact that the heliopause is not a perfectly defined limit adds to the mystery of this region of space. As new data from the Explorer tests and the James Webb Space Telescope continue to come in, researchers are trying to refine their models of the heliopause and how it behaves. This is especially important because we are still in the early stages of studying interstellar space, and the data we gather now could serve as a foundation for future exploration. Space agencies, such as NASA and the European Space Agency, ESA, are already planning new missions to study the outer regions of our nearby planet group and beyond. One such mission is the upcoming launch of the Interstellar Probe, which plans to travel farther than any spacecraft before it. The Interstellar Probe's primary mission will be to investigate the outer limits of the heliosphere and beyond, taking measurements of interstellar particles and magnetic fields. This will provide scientists with valuable data about the structure of the heliosphere and how it interacts with the interstellar medium. The probe will also measure the properties of the solar wind and cosmic rays in the region, giving researchers crucial insights into the behavior of the heliopause and its role in protecting life on Earth. This mission could lead to a deeper understanding of the heliopause and its implications for future space exploration. As we move further into the unknown regions of space, our reliance on these natural barriers, like the heliosphere, becomes even more critical. The data collected from the interstellar probe will help refine our understanding of how our solar system interacts with the surrounding interstellar medium and offer insight into the conditions that other star systems may have. In addition to enhancing our knowledge of the heliopause, this research could have broader implications for interstellar travel. If humanity ever seeks to venture beyond the boundaries of our solar system, understanding how the heliosphere and heliopause protect Earth from the dangers of space will be crucial. As we develop advanced spacecraft and technologies, the role of the heliopause in safeguarding life on Earth and the challenges it presents for interstellar travel will become central to our efforts to explore the cosmos. Moreover, as our technology continues to improve, the ability to measure and understand the properties of distant regions of space, such as interstellar space, will provide essential data for future missions. Understanding the heliopause, along with other cosmic phenomena, will not only contribute to our scientific knowledge, but also shape the future of space exploration and our ability to venture farther into the universe. In conclusion, the heliopause represents a critical boundary in our solar system, protecting us from the harmful cosmic rays that permeate interstellar space. As we continue to explore and study the universe, the role of the heliopause and its changes over time will provide important insights into the nature of interstellar space and our place within it. The ongoing research, including the contributions of missions like the James Webb Space Telescope and the upcoming interstellar probe, will help us unlock the mysteries of this vast and ever-changing frontier. As we look toward the future of space exploration, the study of the heliopause and the interstellar medium could also reveal important information about the broader nature of our galaxy and the universe as a whole. Understanding how the solar wind interacts with the interstellar medium will not only improve our models of the solar system, but may also shed light on the conditions of other star systems. By exploring these distant regions, we may uncover more about the origins of our own solar system and the potential for life beyond Earth. Moreover, the knowledge gained from these studies could have practical applications. For instance, understanding the interactions between the solar wind, heliosphere, and the interstellar medium could lead to better protection strategies for spacecraft and astronauts traveling beyond Earth's protective atmosphere. As humans begin to explore deeper into space, these insights will be vital in ensuring the safety of future missions and the long-term sustainability of human life in space. Another fascinating aspect is how the heliopause behavior might be connected to larger cosmic phenomena. The heliopause is not an isolated boundary but a dynamic feature influenced by various cosmic forces, including the solar cycle, galactic winds, and even the potential presence of dark matter or unknown energy fields in the interstellar medium. The study of these interactions could offer new theories about the fundamental workings of the universe, including the possible effects of galactic phenomena on space weather and climate on distant planets. The exploration of the heliopause and interstellar space is still in its early stages, but the results from current and upcoming missions promise to offer groundbreaking discoveries. The continued success of spacecraft like the Explorer probes and the James Webb Space Telescope is paving the way for a new era of space exploration. As we venture further into the cosmos, the lessons we learn from studying the heliopause will not only expand our knowledge of the universe but will also prepare us for the challenges of interstellar travel in the future. The heliopause, as a key feature of our solar system's boundary, continues to captivate scientists, offering a unique window into the mysteries of space and time. As we push the boundaries of exploration, we move closer to answering fundamental questions about the universe, our solar system's role within it, and the potential for life beyond our own planet. Ultimately, the study of the heliopause is a crucial step in understanding not only our cosmic environment but also humanity's place in the vastness of the universe.